Hello, this is Kwang Hak For this ray tracer reflection texture assignment, our team implement texture mapping for sphere extend the ray tracer to handle UV mapping on spherical objects. Also, implement the correct UV coordinate calculations for spherical surfaces and map a texture image onto sphere. The cube shape was replaced by sphere, and texture mapping was adapted to spherical UV coordinates. Now let me show you the result we got from the code. So this is the result we got. As you can see, compared to the original cube, the shape changed from the cube to sphere, but and the texture remains as this woody shape as in the textbook. So now let's go over the code. Let me go to the code we have made change. So we create the new sphere since we finished this assignment before we got the modified version of the sphere. Let me go over one by one. So for this line, scene equal new scene, we create the new scene object that will store 3D object spheres. And sphere add, new sphere, new vectors, 3, 0, 0, 0, and 1.0. What this means is adds a sphere to the scene, and the center of the sphere is 0, 0, 0, and the radius of the sphere is 1. This replaces the cube shape with the sphere, allowing ray-sphere intersection calculation to take place. And we set the sphere close sphere to null. And for this one, for this loops through all spheres in the scene to check for ray intersections. So if you see here, the ray tracer that intersect ray sphere contains ray and sphere. It's called the method that checks whether a ray intersections with sphere. And if the ray hits the sphere, uh, if the ray hits the sphere, closest intersection is set is to null, or if this intersection is closer than the previously found intersection, update the uh, update the closest intersection. This ensures that nearest object is used for rendering, and this this replaces cube-based intersection logic with sphere intersection detection. And if you see the code I wrote, if the ray hits the sphere, texture mapping is applied here. So calculate the sphere UV close intersection that point and it contains point and close sphere. This converts the 3D intersection point on the sphere into like 2D UV coordinates for texture mapping, and they return the sample texture that contains texture and UV, uses the computed UV coordinate to retrieve the color from the texture and return it. This step maps the texture onto the shape, replacing the old cube mapping approach. And you can see this function converts the 3D point on the sphere into the 2D UV texture coordinates. If you see this like vector 3 a relative point, equals point dot subtracts spears and dot center and normalize it. Moves the intersection point relative to the spear center and normalize it. And this u equal this formula computes the horizontal UV coordinate u using 810 for correct angle calculation and normalize to the range from 1 to 0, 0 to 1. And for this double V with this formula, computes the vertical UV coordinate V using the inverse sine function, also normalized to the range 0 to 1. And return the computed UV coordinate as vector Q UV, which allows texture mapping on a surface, a sphere surface. Mm. And for this 3D transformations, applies 4 times 4 transformation matrix to a vector 3 object. Each XYZ XYZ coordinate is calculated using matrix vector multiplication. This is used for rotating the sphere, ensuring the texture is properly oriented. And there's add vector 3v adds two 3 adds two 3D vectors, this plus v, and subtract v3v, subtract two 3D vectors, this minus v, and these functions are frequently used in like ray tracing and UV calculation, such as finding the relative position of an intersection point on a sphere. Oh, and this multiply here, 3D vector 3 multiply multiplies each component of the vector x, y, z by a scalar value used in ray sphere intersection calculation and normalizing vectors. And, uh, and here it defines a sphere class with center and radius. A center vector, vector 3 center specifying its position in 3D space, and for the radius, double define its size, used to store sphere in the scene and allow intersection detection. And for this mathematical solution, they check whether array intersections a sphere. So if you see this double discriminant equals b squared minus 4ac, which is one of the most famous like formula, determines whether the ray hits the sphere, and t equals negative b minus mass dot square root of discriminant divided by 2 times a. This calculates the closest intersection point, and if the t is greater than 0, the function returns the intersection point and the normal vector at that point. This replaces cube-based intersectional logic allowing the ray tracer to detect spear instead. Yeah, I think this is it for assignment 5. Thank you for listening.